Hey, what's up guys? This video is for section 2-8, which is literal equations and dimensional analysis. So the topic is very fancy, but basically what we are trying to do today is to solve for a specific variable in an equation. So here I have an example, and to solve for a specific variable, first we need to find the variable that we want to get by itself that's solving for one specific variable. And we need to eliminate everything else by doing the inverse operations. So here the example says 3xy plus z equals 3z. We want to solve for x. So notice that we have different variables x, y, and z, and then we have another z on the right side of the equal sign. So when you look for the specific variable, it says here solve for x. Well, the x is right here, and I'm going to put a box around that because that's the variable that we want to get by itself. So we want everything else on the other side of the equation, and to do that, to get everything to the other side, we need to do the inverse operations, which is the opposites. So we need to get this z to the other side of the equation, and we need to get the 3 and the y next to the x to the other side of the equation. So that's the goal for today. We want to solve for a specific variable in any equation. The equation can look different every time, but we need to get that variable that we want to solve for by itself. So let's go ahead and do some examples here. We do have 3 different equations, and I'm going to look at the first one on the left side. And we want to solve this equation, P equals mt for m. So we want m by itself. That's what we want to solve for. We want to solve for m. Now notice that we have different variables, so our answer is not going to be a number like before when we solve equations. This here is going to be some expression, but we need to get this variable by itself. So we have to understand what's happening in the equation. We have p equals m times t. So these two variables are multiplying, and to get rid of the t next to the m, we need to do the opposite of multiplication, which is division. So I am going to divide this by t, and I'm going to divide this over here by t. Now think about the numbers when you divide one number by itself. For example, 7 divided by 7, that's going to equal to 1, or 10 divided by 10, you're dividing the number by itself and it equals 1. So if you look at here, t divided by t, well, that's dividing by itself, so that's going to also equal to 1. So we can simplify this right here to 1. On the other side, we don't have the same variable. They're not the same variable, so we cannot divide those two variables. So we're going to leave it as a fraction, p over t, and we got m on this side, which is by itself. Now you can switch the order by using symmetry property. M equals p over t, and that is how you solve for a specific variable. The m is by itself, and everything else is on the other side. It's not a number. The answer is not just a number. It's going to be an expression. This is an expression here. So this one here, 5q minus r equals 23s, we want to solve for q. So first of all, let's find the variable that we want to solve for. And we want to solve for q. So q is right here. Now imagine, guys, I know I said the answer is not going to be a number, but imagine that the equation has just numbers and one variable, and that one variable is the one you want to get by itself. So imagine that this is the variable, or this is actually the variable that we want to solve for, but imagine that this is a number, like a constant. I know it's not a constant, but you guys just do the opposite of this one to get to the other side. So that's what I'm going to do. I'm going to add r to both sides, plus r, and you can put the line under the equal sign here. And when you do that, you are going to cancel the r's. 1r minus 1r cancels. So you bring down the 5q, and on the other side, the 23s plus r, well, those are not like terms. One has an s, one has an r. So you cannot add those two terms. Alphabetical order, r is first, then s. So I'm going to put the positive r first, plus 23s. And finally, I need to get q by itself. Remember, we want this by itself. So let's get rid of the 5. It's just like before, you can divide by that number by 5. So you can get a 1 right here. We don't need that. But on the other side, you are going to divide everything, the whole thing, by 5. Notice I put a fraction line under everything of that expression and the 5 under. So we have the q here by itself, and we have r plus 23s over 5 for the answer. Now here we have kx minus t equals 2p. So the one that I want to solve for is t. So I'm going to put a box around the t right here. So everything else must go to the other side. Now we have to understand what's happening. We have the kx on this side, and we're subtracting the t minus equals 2p. So this k is actually positive kx. And I know I'm multiplying, but remember that we want to get this variable by itself. So this expression, kx, or this term, has to go to the other side. Since it's positive, I am going to subtract kx, and that's going to equal 0. 1kx minus 1kx equals 0. And I'm going to do the same thing to the other side. So minus kx over here. You can put the line under the equal sign. So we can cancel this kx right here. You bring down the negative t, and on the other side, remember, this here is p. These two terms or variables are kx. They're not like terms. So I am going to write 2p minus kx. They're not the same term, so you put them side by side. And we need to go back here. T has a negative next to it. So I am going to divide by negative 1, and that's because we have an invisible 1 right here. And you divide everything on this side by negative 1. So this here is going to turn to positive 1, and there's your t equals. Now over here, you are dividing by 1, and it is a negative. So first of all, when you divide by a negative, you're going to have to change the signs of the terms, because that's going to turn the opposite sign. And if you divide by 1, well, the term is going to stay the same. 2 divided by 1 is 2. A divided by 1 is A. Kx divided by 1 will be kx. But you have to change the signs, because this negative and this positive here turn to negative, and this negative divided by negative will turn into positive. So my answer will be negative 2p plus kx. And we got t by itself. So let's try a few more here. We want to solve for a specific variable. So let's look at the one on the left side. And we do have variables on each side of the equation. We want to solve for m. Notice that we do have an 4m on this side and minus m on the other side. In the equation, we do have a minus 3n and a plus 8 right here. So first of all, the variable that we want to get by itself, we need to get it on the same side. So I am going to get the m's on one side. I'm going to add m, the smallest m. I'm going to do the opposite of plus m here, and I'm going to add m on this side. So when I do that, I'm going to get 5m right here, 4m plus 1m. Bring down the minus 3n. The other side, the m's cancels, and we have an 8. Now, the variable that I want by itself is the m. That's what we want to solve for. So I need to get rid of this one, minus 3n. And the opposite of minus 3n will be plus 3n. And you add 3n over here. So now you guys can cancel this right here. Bring down the 5m. And on the other side, 8 and 3n are not the same. So I'm going to write it down as 3n plus 8. And finally, you want m by itself. So I'm going to divide. Remember that 5 and m are multiplying. There's nothing in between. So I'm going to divide by 5. And I'm going to divide everything by 5 on this side. This turns into 1 here. 5 divided by 5. So m equals. And you have the expression 3n plus 8 over 5. Now, if you guys have fractions, you can do the same thing as solving equations or linear equations. Is you can get rid of the fractions and then you start solving for the specific variable. So let's go ahead and look what specific variable we want by itself. So we want to solve for a. So a is right here. That's what we want by itself. But first, I do have a fraction 3 over 4, and a minus q equals k. So I'm going to multiply by the denominator, multiply by 4 here, multiply by 4 over here, and you multiply by 4 here. So you can cross simplify the 4's right there. You bring down the 3a minus q times 4. Well, that's just going to be 4q. You always put the number first. And then you guys go to the other side. So the other side, you multiply the k and the 4. So that's going to be 4k on this side. Now remember that we want to solve for a. So let's put the line under the equal sign here. There's the a right there. So let's get rid of the minus 4q. And I'm going to do the opposite. So I add 4q on both sides. And you add 4q on this side. So we can cancel the 4q's right there. Bring down the 3a on the left side. And just be careful with the variables on this side. The 4k and the 4q are not like terms. So you're going to put them side by side. In alphabetical order, k is first. So 4k plus 4q. And the last step is you want to get rid of this number next to the a. So you guys are going to divide by 3. And you divide the whole thing by 3 over here. So this turns into 1. We don't need it. A equals 4k plus 4q over 3 is the answer. Now this one here, the fraction is a little bit different than the previous example. You notice that we have mk on the top minus 2 of the fraction, so that's the numerator, over 5, and then we have equals to 11j. We want to solve for k. Now k is on the numerator right here. So we can get rid of the fraction just by multiplying by the denominator. And the denominator will be 5. So multiply by 5 here and multiply this side by 5. So we can cross simplify the 5's right here. And you bring down the mk minus 2 on this side. And on the other side, you're going to multiply 11j times 5. So multiply the coefficients, the numbers, 11 times 5. That's 55 with a j. Now keep in mind that we are solving for the k value or the k variable. So here's the k. So first, let's go ahead and get rid of this number next to the k, which is a constant. So you're going to add 2 to both sides. And these two cancel right here. So you bring down the mk. And on the other side, these are not like terms. So you're going to put them side by side. 55j plus 2. Now the last step, guys, here's the k one more time. We want to get rid of this variable m. So these two are multiplying. mk is m times k. So we divide by m, and the other side divide everything by m. So this turns into 1. Bring down the k. Here's the equal sign. And the expression, our answer, will be 55j plus 2 over m. Now sometimes when we have a formula that we actually can use in mathematics, we can also solve for a specific variable instead of substituting the values and trying to figure out what the answer is. So here I have two different formulas that we can use in mathematics. And the first one is c equals 2 pi r. Now we know that pi is an irrational number, and we are trying to solve for the variable r. So the variable r is right here. And we have to understand what's happening here. C equals 2 times pi times r. You're multiplying those three different terms. I'm going to put the times in here so you know that we're multiplying. So all we have to do to get r by itself, let's get rid of the 2 and the pi. Now since we are multiplying, the opposite will be division. So I'm going to divide by the 2, that's the one I want to get rid of, and the pi. So the other side, I'm going to divide by 2 and the pi. So when you do that, on the left side, these are not like terms, so you guys cannot reduce the fraction. So you just keep it as c over 2 pi. And on the other side, we know the 2 will simplify to 1, and the pi will simplify to 1. Pi divided by pi is just 1, but we don't need it. And we have the r by itself. Now you can switch symmetric properties, as you can switch your answer. So r can equal c over 2 pi. And the last one here, same thing. You have b equals 703 times w over h squared. Now we want to solve for w. Now w is on the numerator right here. Since we have a fraction, we can multiply everything by the denominator. And it is a little bit weird. The denominator is an h squared, but you guys can still multiply by that. So I'm going to multiply this by h squared and this side by h squared. Now when you do that, guys, remember that these two terms right here, they're not like terms, so you can't really multiply. They're not numbers. You can't really multiply those two terms. So we're just going to put the b with the h squared side by side. On the other side, well, this h squared simplifies to the h squared on the top. So you can bring down the 703 times w. Now I don't need the times in the middle because we know that that's multiplying. You guys see it here, but I don't need it every time. So the last step is to get w by itself. So I'm going to do the opposite of this one. Since we're multiplying, I'm going to divide. So divide by 703 here, divide by 703 over here. So we get b h squared over 703 equals, this turns into 1, which is a w right here. Or you can also say w equals b h squared over 703. So this, guys, concludes my video for section 2.8. If you guys like my video, make sure you guys hit that like button. You can also subscribe to my channel. Make sure you guys practice, and I'll see you guys later.